Today, I'm going to walk you through how I built a controller for this LED strip. So what did I start with and what made me embark on this journey? So I got these 24 volt LEDs off of Amazon. They are actually RGB WW strips, which means that they have an RGB LED there in the center, and then they have a cool white LED and a warm white LED. So at every spot where there's LEDs, there's actually 3 LEDs. The reason I chose to actually do this was because I really liked the color temperature of the LEDs, but I really didn't like the controller that it came with. It just didn't work for what I wanted. I decided to take a look inside and see if I could build my own controller to get around this. So here's a look at that controller, and you'll actually see here a lot of the same components that you'll see in the circuit later on. So we've got some transistors, some resistors, a button, as well as a little controller, which is that thing with the blue thing with the antenna on it. So my test circuit was pretty simple. I just started with some normal standard LEDs, 2 white LEDs and an RGB LED, and an ESP32. I've got the button, then I've got the LEDs, which these are standing in for those transistors basically that you see on the other circuit. And what happens here is when you press the button, it cycles to the next color, which is essentially what I plan to build in my circuit. And the reason I have to use transistors here is because an Arduino can't handle 24 volts. So you can't turn those LEDs on or off using the Arduino directly without blowing up the Arduino. It's just too high of a voltage, it wouldn't be able to tolerate it. So we have to use the transistors to go between the low voltage of the Arduino and the high voltage LEDs. And these pin numbers that I'm using on the ESP in this circuit are not important because basically every digital pin on this controller will work. So the parts list includes the 24 volt LED strip, the ESP32, a buck converter, again to go between the high 24 volts of the LEDs and the low 3.3 of the Arduino, a mechanical key switch, but this could be any momentary switch, the 24 volt power supply of the LEDs, and then both of the wire harnesses that came with the LED set. I can't make something this nice, so I'll just reuse what I have. I also need 5 1 kilo ohm resistors and 5 transistors, 1 for each color. So 1 for red, green, blue, cool white, and warm white. So you could make this work for 3 LEDs, you could make it work for 7 in theory. And also, I'll be sticking all of this into a case to keep everything contained, since this will be going in my kitchen, and try and keep any water or oil or anything like that off of it. So the circuits, we've got the transistors down there at the bottom, we've got the mechanical key switch, we've got the buck converter. I've also made these harnesses, desoldered them from the controller that came with the LEDs, and resoldered the wires to some pin header that I have just so that they would be easier to stick into the breadboard. And now I'm going to set the voltage for the buck converter. As I kind of mentioned before, the Arduino can't handle the 24 volts that the power supply is going to provide. And we can do that with a buck converter. It steps down the higher voltage, the 24 volts, it steps it down to 3.3 volts. And that's something that the Arduino can use, or the ESP32 in my case. That's the function of this. And you can see some of the same circuitry on the buck converter that's on the back of the LED controller. I also added a bit of hot glue onto those pin header harnesses just to add a little bit of structural support, as well as reduce the chance of any sort of shorts or anything happening with those wires. I soldered the wires from the buck converter to the ESP32, and then connected the hot rail from on the left side of the board over to the hot rail on the right side of the board. And I just did that last so I didn't blow anything up by accident. Plug in the 24 volt wire harness, plug in the LEDs to the LED harness, you'll see that all of the LED turns on, which is not exactly what I had designed. I wanted each color to turn on one at a time. Yeah. This is pretty typical for me. I typically cut this part out because I want to look smart. But something's wrong here. And I'm going to show you how I kind of figured it out. So you'll notice over there on the left, I'm pressing the button several times to kind of cycle through each LED state. So that's each of the colors being on and then all of the colors being off. So first it should turn on the red, then turn on the green, then turn on the blue, then turn on each of the whites, and then turn them all off. And you'll notice at one point when I press all the buttons, all of the LEDs do turn off, which means at one point it is working. But it also implies that when one of the LEDs is on, or one of the LED colors is turned on, all of the LED colors are turned on, which implies that there's some amount of, there's some voltage or ground happening somewhere. And that's because I discovered after fiddling around with it a little bit that these large metal backplanes on the transistors are not as electrically separated as I thought they were. So if they're all touching, it means that all of them can turn on when you only want one to turn on. So I bent them all just a little bit out of alignment, and you can see the color actually changes when I press the button. So it's not a terrible thing. We can fix that by just arranging the transistors in two separate rows. So just what I've done here, just a front row and a back row, and now you'll see that each color turns on individually. Whenever I build projects, I still get excited when they work the way I want them to, which I think is awesome. Now that that is working, the colors aren't exactly what I wanted, which means I can go back into the code and just kind of change the order around to get exactly what I want. So I'll fix the code. And add another color. So you'll see here I've got warm white, red, green, blue, cool white, and then purple. I added purple because I like purple and I wanted my kitchen to be purple sometimes. So now with all of that together, the code working the way I want it to, the LEDs working the way I want them to, I can stick everything in the case. This is a pretty simple case that I designed. Feel free to improve on or make a case that's going to work better for you. I feel like another thing I should touch on here is that I did decide to use the actual breadboard in the circuit because I don't know how to design a circuit board. If you don't have a breadboard that has a sticky back, you could just stick it in with some hot glue or something like that. You might also notice that there's two little kind of loops on the case. And I did that because I had initially intended to use zip ties to hold the cables in place as a little bit more strain relief. But I didn't end up doing that. They were just kind of awkwardly positioned. So I kind of nixed that idea. Now I just press the switch into the case. I'm regretting here not leaving longer leads, but now I can just plug the wires back into the breadboard, and everything should be all set. Again, because this case was kind of a first draft, a first design on this, the press fit is also just a little bit loose, so I've corrected that on the model I've uploaded, as well as making it just a little bit taller because I did end up having to tip the transistors forward to get it so that the case would fully close. And like I said, because the press fit's a little loose, I decided to use just a little bit of hot glue to stick the top to the bottom and hold everything together. So just running a bead of hot glue along the top and one along the bottom. and then press it together until it dries, or cools, I guess. There we go. Everything's sealed in, protected from water or any food splatter. We just add a keycap to the top, and we're all ready to install it in the kitchen. So I just installed the case using some command strips, and then to install the LED strips under the counter, I used the clips that came with the LED strips. They're just little plastic clips with basically command strips on the back. The first one, and I'll give you a wide shot. The second one, then we do that half, and the other half, and then we can neaten up the cords, clean off the counter, and there we go. I'm so happy with how this project turns out. This is fantastic. It makes my kitchen so much easier to use. I hope that this video has been useful to someone. Thanks for watching.